Hi, my name is Glenn, and I'm going to show you how to do this little gear set animation. And we're going to go through the geometry nodes, and I'll show you a couple little tricks along the way, and then we'll get into how to set up the animation. I'll go through chunks of that, not all of it, but let's get started. So this is the latest version of my Gearbox 1.2, and I'll be putting that up on the on Gumroad today, and you'll be able to use that. Just a few little bug fixes and some inputs that I noticed that were missing, and that's all. So as you saw in the intro, this is a little animation that modifies the helix angle as these helical gears rotate, and so what you'll see today is not just how to mesh them, we went over that in the intro, but also how to drive them. I've got a simple RPM motor here that I'll show you how to build. And okay, let's get into this. What we've got, just to go through the details of this, for material, I'm just using a simple material. It's metallic, some amount of specular, 0.4 roughness instead of 0.5. And I think the sheen tint, I actually accidentally nudged that, so don't really need that. For the gears themselves, I add a little 4% bevel on these just to make them look a little bit nicer. You can see that around the edges here. For the background, I don't use any lights. What I use is world lights. I've tried a couple things. I've just picked out a Studio HDRI that, and you can use whatever you like to use here. For the render engine, I'm using cycles. So if you're going to use Eevee, you want to set up some lights and do a couple things. I decided to keep it simple. I've got a fairly whippy GPU, so I'm rendering this as a simple preview render with some denoising, and that looked reasonable, and it takes about 10 seconds to do this, so I just ate it. So no big deal on that. We're going to be doing 24 frames per second, 240 frames, so 10 seconds. I think that's pretty much the standard. We're going to do this at 920 by 1080. Kind of massive, but that's okay. I'm going to output pings and then sequence those together. I'm not going to show you that. I'm assuming that you know how to, once you get the animation keyframed, that you know how to do that. Okay, let's dig into this a little bit. Let's just delete everything except for the join at the end of the material. Oh, I didn't show you the studio, basically. The studio is a simple chunk of paper. It's fairly dark. I think the material is no great shakes, just a little bit of surface color, and I kept it rough. It's not metallic, obviously. I think this is the default specular and roughness. I think actually the default for roughness is 0.5, but it doesn't matter. It's got a moderate amount of sheen, but that doesn't really play into the video at all. We're going to make the gears, however, fairly good size. We're going to let's get back here and back to geometry nodes. What I meant by fairly good size gears. Let's step back here and just look through our frame. This is our render frame, and I'm going to use helical gears for this animation. And I have a tendency when I'm just playing around with gears, instead of using 30 centimeter gears, I'm going to use like 300 centimeter gears. Basically, it's kind of nice having larger gears. It's a little bit easier to play with as far as Blender is concerned. This has to be a little bit taller, and we need a little bit bigger hole radius, or it looks a little bit nicer with a good size hole radius. And I'll show you how to place these real quick. We learned how to do that in in the intro. The important part is we'll learn how to set the speed ratio for both gears and get them animated properly. So, except the important thing about putting two gears, meshing two gears, I'm going to Shift D and create a second gear. The important thing is having the same module. And in the intro, we had a value that we calculated the module based on the size. We're just going to use a good size to start with. The second gear is going to be something besides 12, so we'll have you'll be able to see a speed difference, and it'll be a little bit larger in the composition. And when we join those up, we have the same problem where they just overlay one another. And the way you fix that is we'll translate the right side gear so that it is the right space along the x-axis. And the way we do that is by adding these two pitch radii together, right? And let's bring these out away. So we combine these along x, and I use x just as a matter of convenience. You can use y. And as always, we may have to adjust this by half pitch rotation to get it to line up. And also with helical gears, they have to not only be the same rotation, 20 degrees here, but one is an opposing twist to the other one. So once you get that together, you've got some meshed helical gears. Okay, so that's it for meshing. Let's take a quick look at how you would rotate these for animation. We're going to just tweak the rotation in the transform node. So we're going to be rotating both of these. We're going to be setting a rotation on the front one, and whatever that rotation is on the bottom one, we have to adjust it by gear ratio. Let's work on how we're going to drive these gears first of all. Let's go full size, and I'll show you that node group. What we're going to do is use an input called scene time. So what we're creating here is a motor. We're going to use the seconds output to drive an RPM motor. We can set the speed by RPM. It's a convenient way to think of things. I think most people know, maybe it's old folks that just know what 33 and a third RPM looks like. Anyway, the first thing we're going to do is modulo this by 60. So every 60 seconds, this resets. We're going to take that and then divide by 60. Okay, so what we've done here is just create a mechanism that generates, as seconds tick by on our timeline, will generate 1/60th, 2/60ths, 3/60ths, so forth, and then after 60 it'll reset. So it's just a little driver. The next thing is to, this should be a divide, sorry. And the next thing we're going to do is multiply this times 2 pi. You can use the keyword tau here. And now we have a 1 RPM driver. We have to multiply this to get our RPM, right? So we're going to take this and eventually plug this into an input so that it will be, right now we'll just keep it at a 1 RPM. And the output that we're going to spit out, I'm going to combine this on Z. So what we've created here is what amounts to a rotational vector. Now the default for this is to go from 0 anti-clockwise around a circle. So we're going to keep that, but I also want to have one that goes clockwise. And the way I'm going to do that is to negate this one, as simple as that. We're going to multiply it by -1. and put that in Z. That's clockwise. Whenever I have these real simple nodes, I like to remove, oops, not that one. I like to remove the unused inputs and make them small and just give them a title, F2. It kind of simplifies things. I don't have to look and see what I'm multiplying it by. I don't accidentally hit it and do the wrong thing. So now what I want to do is make this into a true-to-life node group. So we just select them all, Control G. We're going to hook up our multiplier input into here. That's going to be our RPMs, RPM input. And we're going to just output these two vectors. So for the input value, we have RPM. We have a default of 1. Let's make a default of 10. Top one is clockwise. And second one anti-clockwise. Cool. And that's our node group. So the way we use this, simple enough. We set whatever, I'm going to call this motor, and whatever value we want on this motor, and we have two rotation vectors output. So the first one is a simple connection. We're going to drive the first motor in a clockwise direction, and we're basically all done with this top guy. He's going to go in whatever speed we set here, 10 RPM. But for the second one, we need to adjust the speed. We're going to send it in the anti-clockwise direction, but we need to adjust the speed by the gear ratio. And that gear ratio is my typing, man. Is not the pitch radius, sorry, is the number of teeth. We're going to divide the teeth of the first gear by the teeth of the second gear. And that's the ratio by which we have to adjust this motor in the anti-clockwise direction. To do that, we'll just combine here in onto Z and then do some vector math. Obviously, for vector math, we could have used floating math and separated these out, or output float values here. I'm trying to keep this as clean as possible, but so this works, right? So we've multiplied x and y still remains 0. This is a rotational vector. It's simply going around the z-axis. And that's going to be our input to the rotation on this guy, and he's also complete. So we're all set to take a look at the mess we've made. Okay, we're all lined up. And it's interesting to look at this because this isn't physics. We're just driving this one in the clockwise direction, 10 RPM. And we're driving this one as it's meshed in the negative direction, adjusted by its gear ratio. So it stays together properly. We could make this as big as you wanted to. Obviously, it gets slower because the gear ratio changes. We can make this smaller, and this now gets greater than, the RPM is greater than the first one. Okay, standard gear stuff. We're going to keep this at 16 because, lo and behold, that fits in our frame as planned. Okay. So in the video that I showed you, what I did was tweaked the helix angle of this guy, and I wanted to show that a little bit. If we were to take this, let's bring an input. We're going to need an input. It's just going to be a floating point value. Right now it's 20, so let's just put it that so this doesn't change when we connect it up. Okay, and the bottom one goes to 20. And when I first, let's break this real quick. In the current version, I've stopped these at the top 45 degrees, so you can't take it greater than 45. And I've stopped it at the bottom at 0. And as you might notice, at 0, it's a spur gear with some Z faces on it. An actual spur gear is, just has the one face. But when you pull these, let's take it back to where it was. If you pull these out and connect them to an input node, this is true with any geometry node, now you can take these however you want. You can take them below into the negative area. You can take them past 45 and that sort of thing. So we're going to play with this and tweak this throughout the video. And so when you're doing a timeline, this could be your setup, and your timeline you could just do linear moves or set up the moves and then use the graph editor. I find it's a little bit easier just to set up a math node and just use a trig function. It's my preference. Cosine is convenient here because if you started at 0, the cosine is 1. It's the radius over adjacent over the hypotenuse unit circle. So at 0 it's 1. At pi over 2, 90 degrees, it's 0. At 180 degrees, it's -1. So it's a very convenient thing to push this through, just in your timeline, be tweaking it by pi, and then multiplying it by this value. So that's exactly what we're going to do. We're going to take this and do a multiply on this from this value, these two values together. Do a multiply, and that's our setup. Okay. So what we've done here, we haven't changed the video yet. We have to do some keyframes, and I'm not going to go into all the keyframes I do, but I'm going to show you how to do them real quick, and you can mess with them however you want. In fact, we're going to do a simple keyframe instead of the multiple ones I did, where let's just set up some keyframes real quick. First thing I'm going to do is take this cube value, take this, and add it to the keyring set. And we're at 0, so I'm just going to keyframe this. Okay, so we've got a keyframe at 0 with it at 0. 1 second later, at 24 frames, remember we're at 24 FPS, we're going to keyframe this again. So for the first second, it stays flat. And in fact, since we've got all these, let's go ahead and do it at 240. We're going to keyframe. Now it's just confusing to do it that way. Let's go to the third second. Okay, 72. And what I'm going to do is keyframe this at pi over 2. That's 90 degrees. Do an insert. And a second later, so we've transitioned, this is a transition here. Oh, I'm sorry. Yes, this will transition here, and here it will stay stable, so we'll keyframe that again. So our transition here takes 2 seconds at this point. Let's see if we've got this right. Yeah. And it stays here. One thing is that I'm not all that crazy about it taking so long to make that transition. So at at this one, let's take a look at this. Play with that. At the next one, we're going to transition and make a faster transition. We're going to go from here to here. See how that looks. All right, let's go to slowly, quickly. I kind of like the quicker going. Anyway, you get the idea. You can play with these and do whatever kind of keyframes you want to do. I kind of like the 1 second transition. It looks a little bit cuter, but you can play with it all you want. And that's it. Hope you enjoyed the video. If I come up with any more ideas or get any requests, I'll let you know.